So today we will be dealing with circle theorems, and our learning goal is for everybody watching this to be able to solve circle theorem problems. The following questions involve solving circle theorems. Use your knowledge of geometry, angles to prove the given problems. Now let's go to question number one. It says PQR are points on the circumference of a circle. P, Q, and R are points on the circumference of this complete circle. Now with center M, so the center is M. PMR is the diameter of the circle, so the line PMR is the diameter, that is the line that divides the circle into two equal halves. Now prove that angle PQR is 90 degrees. Prove that angle P, Q, and R. When we say angle P, Q, and R, that means the angle at the center here. So it's the angle here. That will be the total angle at the point Q is 90 degrees. That is what we want to prove here. You must not use any circle theorems in your proof. So you are not allowed to use any preformed circle theorems. Now, how do we work this out? Using the triangle and angle reasoning only. Okay, because I can tell you there are two ways to this. I will show you the second ways, but I will not work it out. I will show you the second way. So let's go to the first easiest way. Let angle PQM equals to X. Angle PQM. That means when I say angle PQM, meaning angle at points what? At the middle. Angle PQM, that means this angle here, let it be angle X. So I'm going to put X as the value. I will put X as the value. Okay. Now I've settled this step. Let angle RQM be equal to Y. So angle RQM. Angle RQM, meaning the angle at the center, let it be equal to Y. Let it be equal to Y. So I'm going to write the angle at point Q here. Let it be Y. So I'll put this angle as Y so that we have established second step. Since MP, so let's look at MP. What is MP? MP is a radius. Can you see that now? It's a radius from the center here. So M to P is a radius. Is equal to MQ. MQ also from M to Q is also a radius because it starts from the center of the circle to the circumference. Also MR. And see MR also is also a radius. So we can easily say that MP is equal to MQ and MR also equal to MQ. They are all radii. That is established, which means in triangle PQM, let's look at triangle P, Q, and M. PQM, triangle PQM. So we are looking at solely triangle P, QM. This triangle, it means it is a what? It is an isosceles triangle. It means it's an isosceles triangle. So if it's an isosceles triangle, that means angle PQM, let's look at PQM. Angle PQM is X, also is equal to angle MPQ. Angle MPQ. This angle here is also X. That is to simply tell us that two base angles in an isosceles triangle are equal. Two base angles in an isosceles triangle are equal. So if I'm bringing it out now, you see it's very easy for me to bring it out. I could say this is the triangle we are looking at, angle P, Q, and M. So angle X here, because this is a midpoint, P to M is equal to M to Q. So that triangle is an isosceles triangle. So we can establish that the two base angles are equal. That's why I put x and x in this place now. So having established that, let's look at another one. So I've finished this step. Triangle QRM is isosceles as well. So let's look at triangle QRM. So looking at triangle QRM, this triangle, I could bring it out as well and say this is triangle QRM. Q is here, R is here, and also M is here. So if I have this as point as angle Y, that means this side also is angle Y. So I could put this place as Y as well, because the two base angles are equal since it's an isosceles triangle, and it is an isosceles triangle because M to Q and M to R are equal. They are both radius. They are both what? They are both radius. So we can see how easy this is, right? So we have established that one, and now we can see that we have 2x and 2y on the triangle. Now, so I'm able to actually explain why we pick these steps. Now, let's go to the next step, which says look at triangle PQM. Triangle P, Q, and M. All right. So also that isosceles triangle again, the angle at point M is equal to 180 minus 2x. Why? Because let me draw it again for us to see. We are considering triangle P, Q, and M. Now we can establish that angle PMQ, that is the angle at the center, which is this angle here now, will be equal to 180 minus 2x. That is, this is x and this is another x. Now that remaining angle PMQ will be 180 minus 2x, because the total angle in the triangle is equal to what? 180 degree. So if I remove the 2x, this x and this x from the 180, it will give me the remaining angle, which is the angle M. That's what we call angle PMQ. Okay, and that's why we got this one. Now let's go to triangle QRM, which I will draw here as well. Triangle QRM, so Q here, M, and R. We've established that at point Q we have angle Y, and also at point R we have angle what? Angle Y. That means the angle at this point, which is angle what? QRM. Angle QRM will now be equal to what? Angle QRM will now be equal to 180 minus 2y. Okay, that means we take away this 2y away from it to get the remaining angle at that. That means this angle and this angle have been sorted out as well. That is, angle PMQ is what? Is actually equal to 180 minus 2x, while angle QMR is actually equals to 180 minus 2y here. Okay, that is settled. So we can really establish that one. Thank you. So what we do now is easy. Now what we do now is very easy. We will now consider the line PMR, which is a straight line, and see that, which is a straight line, and that means the angle at the midpoint, okay, is equal to 180. The total angle at this place now is 180 because it's an angle on a straight line. So that 180 is equal to PMQ, which is what? 180 minus 2x plus QRM. Look at it, this one plus this one. The total of it is equal to 180. So let's add it together. So we can say that 180 this 180 is equal to what? The PMR and QRM. Okay, therefore if you continue to do this, you see 180 plus 180 here will give us 360. 2x minus 2x plus minus 2y, that is minus 2x minus 2y equals to 180. Then I can collect the like terms, isn't it? If I collect the like terms, I have 360 degree minus 180 equal to what? These two minus 2x and minus 2y will move to the other end as well, and that will give us 2y plus 2x. So 180 is equal to 2y plus 2x. So I can factorize that and say that 180 is equal to 2 into bracket x plus y, and I can divide both sides by 2, isn't it? Divide both sides by 2, which will give me 90 equals to x plus y equals to 90 plus y. That means x plus y, which is initially what we have at point Q that we are looking for, is equal to 90 degree. Therefore, angle PQR is equal to x plus y and is equal to what? 90 degree, which is very, very easy. I need to do this explanation in addition to the steps I've put here, and I believe that if you go through the step I've put here, it's even easy to understand, but I need to put this little explanation for us to get it clearly. Alright, thank you so much. So the next thing I will do now is to go to question number 2. This one is question number 1, but in another form. It can be done in another form, but this is a little bit complex. We'll do it when we get to equation of circle. It's also easy, okay, but just for your test, you can just check it. Let's go to the next question now, question number 2. Question number 2 talks about, now question number 2 says AD and E are points on the circumference of a circle, center O. So this is center O here. AD and E, they are points on the circumference of a circle. Prove that angle AOE is twice the size of angle ADE. So this is angle AOE here, and this angle ADE. We are saying that if this angle is 2x, this one is supposed to be only x. That's what we have been asked to prove now. Now, you must not use any circle theorems in your proof. Okay? Now, let's follow the step one after the other. It's very easy, and I will explain why. Let angle ADO equal to P. Angle ADO. So this angle here, let it be P. Okay, so I'm going to write this as what? As P. Now, let angle EDO equal to Q. Angle EDO. That is this angle here equal to Q. So it's like saying the whole of the angle at D equals to what? P plus Q now. Okay, that settles the matter. That will just give an assumption, and we have finished this 2 step. Now, since OA equal to OD, let's look at OA. O to A is a radius, and is also equal to O to D. O to D, also radius, because from the center to the circumference is equal to what? The radius. That means this angle here also supposed to be what? Angle P, because it's an isosceles triangle. Okay, that's why we say angle OAD, angle OAD. That is the angle at the center. This one supposed to be on what? Angle P as well, because it is an isosceles triangle. It is an isosceles triangle. So I'm going to write angle P degree here as well. Now, if you look at also, if you look at OA and OE, let's go to it now. OE and OA, they are also radii, and also OD also, if you look at O to D, is also a radius. That means we can easily say that angle OED, let's check it, angle OED is Q is also equal to angle ODE. Angle ODE. So this angle is also equal to Q, because it's now a what? An isosceles triangle, just like what we had the other time. Okay, it's now an isosceles triangle. So we have angle O here, we have E here, we have D here. So if this is Q, this one also is what? Is Q, because OE is equal to what? Is equal to OD. They are both radius, just the same way we have this one as well. Okay, just like O, D, and A. So OA equal to OD, meaning that this and this are radius. That's why we have P here and also equal to P here. It's very easy. So the angle here and here, we can find them, isn't it now? So in triangle AOD, let's check it together now. AOD, that means the same triangle that we're looking at AOD. This is the triangle. That's the one I draw out here. Okay, angle AOD, angle AOD. That is this angle here, which is here, is actually equal to what? 180 minus 2p, which is clear. Okay, this angle is 180 minus 2p. So I sort this one out. In triangle OED, this triangle OED as well. So angle DOE, that is the angle at this point, is also equal to 180 minus what? 180 minus 2q, because this place you have to, since the total angle in the triangle is 180, take away q and q. That is 180 minus 2q. Will give us the remaining one. Okay, and that is also settled. All right, that is also settled. Now we have sorted out this and this one. Okay, now in triangle ADE, let's check the triangle together. Triangle ADE. In triangle ADE, let's check it now. That is the bigger triangle ADE. This bigger triangle now. What can we say there? Okay, ADE. Angle ADE is what? P plus Q. We have seen it already. I just said that the angle at D is P plus Q. That is sorted out already. Angle AOE is equal to what? Angle AOE, that is looking at triangle. Angle AOE, looking at triangle what? This triangle. Okay, so we have 360 minus AOD minus DOE. What's our AOD? AOD is 180 minus 2p. Okay, DOE, we have seen it already. That's 180 minus 2q. Okay, so that means the angle AOE, that is this angle, okay, is equal to 360 minus what? Minus this and this, which is easy, which is 180 minus 2p and also 180 minus 2q. So we want to subtract it away from me. That means 360 minus this, which means 360. So 180 and 180, that is 360 minus 2p minus 2q. So we have 360, we take away 360. So we are left with angle AOE equal to what? 2p plus 2q. That is what is remain there, right? So if I factorize 2 out, I will have 2 outside and we have p plus q. Okay, factorizing it out. However, we can see that ADE, which we have established also, angle ADE is what? Is this now. Okay, which is this. That means angle what? Angle AOE is twice angle of ADE. Can you see that now? Twice the angle of ADE. And that means we have been able to establish that angle AOE is twice the angle of ADE. Can you see that now? It's twice the angle of ADE. And that's sort out our problem here. That's also very clear to everybody. Thank you. Let's go to the next question now. Our aim is to be able to solve any question under circle theorems, and we are considering the main theorems in, the main theorems in circle theorems in this topic. Okay, so feel free, if you have any question, you can put in the chat box for me. Now let's go to question number 3. What does question number 3 says? It says that P, Q, R, and S are points on the circumference of a circle. So P, Q, R, and S are points on the circumference. Prove that angle PQS and angle PRS are equal. Angle PQS, we're looking at this angle, and angle PRS, meaning this angle. So we are looking at this angle and this angle. We want to prove that they are equal. So what can we do? Let angle POS equal to what? Y. So let's put it there. Angle POS. Let it be what? Let it be Y. Angle POS equal to Y. So this angle, let it be Y. That means angle PQS. Remember? Angle PQS, angle PQS. This angle here will now be half of Y, because angle at the circumference is half this angle at the center. So this is half of Y. This is 1/2 of Y. Because of this reason, we have proved this earlier on in question 1, question 1 above. We have proved that earlier on, and that is why we could just establish it now. You can see that in this question we are not restricted from using circle theorems. Okay, now if that is the case, we could also say that angle PRS is also equal to what? Half of Y, because PRS and PQS are both subtended by the same minor arc here. Can you see it? This minor arc. Okay, it is this same minor arc PS, that actually subtends angle PQS and also angle PRS and also angle POS. All right, now PQS and PRS are equal because they are both subtended by the same minor arc, okay, in the circle. However, each of them are half of what? Half of the angle at the center, even though they are subtended by the same arc PS. The angle at the center of the circle, which is this one, angle POS, okay, will now be twice the angle at the circumference. So don't forget this one. We have been able to prove this one as well. So let's go to question number 4, which is also another a very fantastic one, and we'll be making use of what we have learned so far now in question 1 and 2, even 3. So circle and supplementary angle, this is the one on that one, says PQRS are points on the circumference of a circle, center O here. Now prove that angle PQR and angle PSR add up to 180. So let's go to angle PQR. This is angle PQR. Angle PSR is here. That if I add the two of them, they're supposed to be equal to angle 180. That's to tell you that in a cyclic quadrilateral, the opposite angles add up to 180 degrees. That is what we want to say. And also we can also prove that this one and this one will add up to become 180 degrees as well. That is a theorem in this topic. Okay, now how do we go about this one? Let's also say that the minor arc POR, angle POR, this arc POR, let it be U, and also the major angle there, POS, the major angle, this is this one, which is the bigger one, let it be V. So automatically U plus V equals to 360 degrees. That is very clear already, because angle at a point equals to 360 degrees. Angle at a point equals to 360 degrees. So U plus V equals to 360 degrees. We can always establish that. That's why we even use this one here. So when we get there, you see it. Now we have established this and this one. Let's now say that angle PQR angle PQR is equal to half U. How? Angle PQR, because that angle is subtended. PQR, look at it, is subtended by this arc. Okay, it's subtended by this arc. All right, and then it's equal to half of U. It's equal to half of U because the angle at the circumference is half angle at the center. Now, so we established that this is correct. Also, angle PSR is equal to half of V. Angle PSR is half of V because angle subtended at the circumference is half angle subtended at the center. Okay, so we can establish this one. That means angle PQR and angle PSR is equal to half V plus half U. Okay, plus half U. So this is it here. We add them together, half U plus half V. Okay, therefore it's equal to half of 360 degree because we know that U plus V is what? 360 degree. So half of them is half of 360 degree, and half of 360 degree is equal to 180 degree. Therefore, PQR plus PSR is 180. It's 180 degree, which we have been able to prove because they are half of U plus half of V. When we add them together, okay, when we add this together, they are half of what? Half of U and half of V, which is what? 180 degree according to our proof. So it's very easy to prove this one now. Okay, thank you. Let's go to number 5. Question number 5 here. That means we have looked at 5. We are looking at the 5th theorem. Okay, very cogent ones. Okay, now let's look at PQR on the points of this circle, and we have a tangent. Okay, TQS also is a tangent. Prove that PQT and angle PQT and angle PRQ are equal. So PQT, let's look at PQT. PQT, that is the angle here. Okay, is equal to angle what? It's equal to angle PRQ. So we have PRQ. So the angle here. So we want to see why and how this angle will be equal to what? This angle here. Let's make sure that this is y, angle y. Okay, that will be very easy for us if you put that one there. Let's say it's angle y. Okay, so we want to prove that they are equal. We want to prove that this angle and this angle are equal. So let's PQT equal to what? Angle y. We just assume now that PQT is equal to angle y. Then since OQ is the radius and TQ is the tangent, O to Q, you can see O to Q. Okay, so you can say that the whole of this is 90 degree. So an O, because the tangent and the radius meet at angle 90 degree, so we can say that this is valid. OQT is 90 degree because the angle between the tangent and a radius, this is O, this is Q, this is T, and this is what? This is S. Okay, this this TQS is 90 degree to QO or OQ, because O to Q is what? Is a tangent, is a radius. So let me draw from center here, radius to this point. Okay, that's perfect as well. I'm drawing that one for a particular reason. You still see it now. Okay. All right. So let me draw this line and let me clean this one for us to see clearly so I can use it again. Now in triangle OQP, let's look at it. O, Q, and P. Angle OQP is 90 minus y. Angle OQP is what? This angle is 90. Take away y, okay, because you know this place is already y, and the whole of it was already 90. So if you want to know that small angle is also 90 minus y, we've gotten that one. Now if you have gotten that, that means, and let me bring it out completely. You see what is happening here? This is point O now, this is point Q here, and this is point what? Point P here now. In which this place now is already 90 minus y. Okay, I want to believe that you know that this place also is 90 minus y. Why? Because it's an isosceles triangle already. P to O, this P to O is a radius. This also P to O is also a radius. Q to O is a radius, and P to O is a radius. So it's an isosceles triangle, which means the base angles are equal, 90 minus y. If we have that one, that means this point angle O here will now be what? 180 minus what? You take away 90 minus y, take away another 90 minus y, which means we have 180 degree minus 90 plus y, because this minus will multiply the minus here, giving us what? Plus y. Also we have this minus will multiply the minus here, become plus. That means minus 90 here plus y again. So we have 180, 90 plus what? 90 minus 90, that means minus 180 degree plus 2y. Okay, that means this cancel away this, that means equal to 2y. That means this angle O equals to what? 2y. If angle O is 2y, so if angle O is 2y, that means at that point, at this point, we have O equal to 2y, angle O equal to 2y. That means that is an angle subtended at the center of the circle, right? Any other angle subtended at the circumference by the same arc, all of them, look at it, they are all subtended by the same arc. Angle QRP is subtended by the same arc. Angle what is this one now? Angle QUP also subtended by the same small arc. That means they will be half, which is y and y. Now, if you say it is y and y, you see that this place is y already. We assume it is y from the beginning. That means we have been able to prove that angle PQT is equal to angle PRQ. See that now? Angle PRQ is y. Also PQT is also y. So it's very easy, right? So we have employed and we have actually used another, circle theorem there to prove our point. All right, that is another proof done, and that is number 5. All right, and now if you want me to prove another circle theorem, I want you to just try to tell me in the chat box, and I will prove anyone. Okay, but you can see, if you want me to have a one-on-one session with you, maybe to prove other theorems for you easily, please reach me on this number. It is +234 810 3277 436 on WhatsApp. You'll be able to join my WhatsApp channel as well. On my WhatsApp channel, I have solved almost all the questions there. Okay, so you can easily join it for free. If you want to have a one-on-one session with me, you can book. Okay, you can reach me on this WhatsApp. Also, you can reach me through my my email address as well. Thank you, and I will see you in the next class. Bye bye. Thank you.